Here we are, we're going to be talking about adding and subtracting rational expressions. But before we can do that, let's talk about how to add and subtract fractions without variables. So as we recall, to add fractions that do not have variables, they still have to have a common denominator. And then we add the numerator, so 1 plus 1 would give us 2, and the denominator stays the same. Right? The numerator says how many, and the denominator says the size. So we have to have the same size pieces that we can add, and when we add them, the size doesn't change. Then once we've added, we can simplify the fraction if there's any common factors. We're going to do the same thing here. In this video, we're specifically going to be talking about adding fractions that already have a common denominator. So in this first example here, we have x over 6 plus 7x over 6. They already have the same denominator. We add the numerators. So x plus 7x would be 8x. This denominator stays the same. When we add them, the denominator doesn't change. Then if we can, we divide out any common factors. So I see a 2. I can divide out a 2 from the numerator and denominator and get 4x over 3. And that's as far as we can go. Same thing here. They already have a common denominator of 6c plus 27. We add the numerators. Now be careful. This is 4c plus 18. They are not like terms. So we can add them into the same fraction, but we can't actually add them. They're not like, so they cannot be added together. Once we've added them, we check to see if there's anything that we can factor. So in the numerator, I see the GCF of 2. I'm going to go ahead and pull out a 2 in the numerator. That would leave me with 2c plus 9. I have to factor the denominator as well. I see a GCF of 3. When I divide out a 3, that leaves me with 2c plus 9. And once I've factored it completely, I see a common factor of 2c plus 9. So I divide that out. Anything divided by itself is 1. And so that whole thing goes down to 2/3. Go ahead and try the 2 on the right. Alright, here we are on the right hand side. They already have a common denominator. We have to be super careful with this subtraction. When we subtract, we're subtracting everything. So you actually have to distribute that negative to everything. This is the same thing as a minus 2. Right? This was a positive a, now it's minus a. So it was a positive 2, now it's minus 2. All over 5b cubed. But a minus a is 0, and we're left with just a negative 2 over 5b cubed. Remember, when we add or subtract, the denominator doesn't change. That 5b cubed stays the same. We simplify the numerator as much as we can, check to see if anything factors out. It doesn't, we're done. Alright, this next one. They already have a common denominator, so I combine them into one fraction. They are not like terms, so I can't really subtract 9 from x squared. But when I get it together, I see in the numerator that x squared minus 9, that's a difference of squares. So it factors into conjugates. X times x would give us the x squared. 3 times 3 would give us the 9, and we need one positive and one negative to complete our conjugates. And once the numerator is totally factored, I see a common factor here of x plus 3. We divide that out. So now we have x minus 3 over 1, or just x minus 3. And that's as far as we can go.